My dear students and parents, in this video we are going to see the sum example 32 in the chapter continuity and differentiability in the subject mathematics to the +2 Cbse students. It is also very useful to the IIT students. What is the sum? Differentiate x to the power sin x, x greater than 0 with respect to x. By God's grace, my educational videos are available in YouTube to 9th Cbse, 10th Cbse, +1 Cbse and +2 Cbse, NEET and IIT students in the subjects mathematics, physics, chemistry, zoology and botany in English language. Before proceeding the differentiation, we should note 5 points. The first point is we need an equation relating two variables, generally x and y. Here there is no equation relating the variable x and y, but we can consider the given function as y. If we consider the given function as y, we will get y equal to x to the power sin x. Now we are having an equation relating the variables x and y. So the first condition is satisfied. Then coming to the second point. After getting the equation relating to variables, we should see how many terms are there in the given function. Why we should see how many terms are there in the given function? Because each term should be differentiated separately. We cannot differentiate 2 or 3 terms combinedly. So that we have to see how many terms are in the given function. In this sum, there is only one term, so that we need not worry about it. The third point is, what is the coefficient, what is the variable, or whether a constant term has come. We have to confirm, because each data will be given a separate treatment on differentiation. The coefficient will remain as it is on differentiation. The variable can be differentiated. If we differentiate the constant, we will get 0. So that we have to confirm what is coefficient, what is variable and what is constant term in each term. Don't forget. After that, the fourth point is we have to see whether the variable x has come with one function or 2 or more functions. If the variable comes with 2 or more functions, we should differentiate as per the chain rule. That is function of function rule. That is as per the composite function rule. Note the function. Can we differentiate this function as per the power rule of differentiation? Sir, you have stated in many videos, if the variable comes with the power, we can differentiate as per the power rule of differentiation. That is the power of the variable will become the coefficient of the variable and the power should be reduced by 1. So that can we differentiate just like this? No, no, no. dy by dx equal to sin x, the power has come as coefficient and power is reduced by 1. Then on differentiating sin x, we are getting cos x. We cannot do so. Why? What is the reason? The reason is here the power is not a real number. If the power of the variable is a real number, that is, it is the whole number, or it is the positive integer, or it is the negative integer, or it is the fraction, we can differentiate as per the power rule of differentiation. Here, in the power, there is no real number. That is, the variable comes along with the sine function. So, how can we differentiate this? First of all, we should bring this power sin x as the coefficient. How can we bring this power as coefficient? We know the power rule of logarithm. What is the power rule of logarithm? Log m to the power n equal to n into log m. So this power has come as the coefficient. Similarly, if we take the logarithm on both sides, we can bring this power as the coefficient. Taking logarithm, we will get in the left side log y, in the right side log into x to the power sin x. Then we are bringing the power sin x as coefficient, so that we will get the function as log y equal to sin x into log x. Here also we have to be very careful on differentiating. That is, when we are finding the derivative of this function. Y, what is the variable? The variable is x. In the fourth point, we have clearly stated that whether the variable comes with only one function or with two or more functions. Here, the variable x does not come with two functions. There are two functions. One function is sine, another function is log. But the difference is, in this case, first of all, the variable x comes with the function sine. After that, the same variable x comes with the function log. The variable comes two times. Moreover, it has come as a product, so that we have to differentiate as per the product rule. Suppose if the function is like this, that is log y equal to sine of log x, we can differentiate as per the chain rule. That is as per the function of function. Why? Because here the variable x has come only one time, but it has come with two functions, so that we can differentiate as per the chain rule. Here we cannot differentiate as per the chain rule. Note the difference between these two functions, that is between these two equations. This is very important. Many times many students are confusing whether they have to differentiate as per the chain rule or as per the product rule. So that note the difference. Here the variable comes 2 times, that is the variable x comes 2 times. First the variable comes with the sine function, then the same variable x comes with the log function. The x has come as a product also, so that we have to differentiate as per the product rule. What is the product rule? The product rule is u dv plus v du. What is u? The first function is considered as u. The second function is considered as v. So that u is written as sin x, v is written as log x. So on differentiating sin x, we will get cos x. That is du equal to cos x. We know that on differentiating log x, we will get 1 by x. That is dv. So in our hands, we are having u, v, du and dv. If we substitute all these 4 data in the equation u dv plus v du, we can get the result. See all the functions on the board. The function is written again, that is log y equal to sin x into log x. First of all, we are going to differentiate the left side. In the left side there is log y. On differentiating log y, what we will get? We will get 1 by y. Then we should differentiate the variable y. Thereby we will get dy. To which variable it is to be differentiated? It is to be differentiated to the variable x, so that we will get dx in the denominator. Coming to this formula, first of all, u is written, that is u equal to sin x. Then dv, that is differentiation of what is v? Log x plus log x. What is this log x? This is nothing but v. Then we are going right du. What is du? Differentiation of u. What is differentiation of u? Differentiation of sin x. Finally, we should definitely differentiate the variable x. It is also very important. Why? Sometimes if the variable is other than x, we will forget to write dy by dx. So that it is advisable to differentiate the variable x to the same x, so that we will get dx by dx. Dx by dx equal to 1. For that reason, we are not writing this dx by dx in the last, but it is advisable to write this. Then we will get 1 by y into dy by dx equal to sin x. On differentiating log x, we will get 1 by x plus log x. On differentiating sin x, we will get cos x into 1. This is u, this is dv, this is v, this is du. Then we are bringing this denominator y to the right side, so that we will get the equation dy by dx equal to y into sin x into x to the power minus 1. Why I am writing as x to the power minus 1? If we bring this denominator x to the numerator, it will become as x to the power minus 1. So that I am writing as x to the power minus 1 plus log x into cos x. Then we have to substitute this x to the power sin x in the place of y, because in the left side we will have the variable y, and in the right side we will have the variable x. So that we are going to substitute y as x to the power sin x. This is the given equation. Substituting the given y equal to x to the power sin x, we will get dy by dx equal to x to the power sin x into sin x into x to the power minus 1 plus log x into cos x. Within the bracket there are two terms. There is also a common factor. Can we multiple these two terms contained within the bracket with this common factor? Yes, we can multiple. If we multiple these two terms with the common factor, we will get dy by dx equal to x to the power sin x into sin x into x to the power minus 1 plus x to the power sin x into log x into cos x. Then we are going to write x to the power sin x and x to the power minus 1 nearby. Why should we write nearby? Because we know that if the bases are same, the power can be added. Here the base is x, here also the base is x, so that we can add the power. So that we are writing x to the power minus 1 near to the x to the power sin x. So that we will get dy by dx equal to x to the power sin x into x to the power minus 1, then this sin x plus x to the power sin x cos x into log x. I am interchanging the factors, that's all. Finally, we will get dy by dx equal to x to the power sin x minus 1. If I add these two powers, we will get sin x minus 1, sin x plus x to the power sin x into cos x into log x. My dear students, in this one sum, we have seen many concepts. If this video is really beneficial to you, you can share this video with your friends, classmates and relatives. You can also subscribe my channel.